So let's solve the PTM2 paper. First question is, in a car race on a straight road, car A takes time t less than car B at the finish and passes the finishing point with a speed v more than the car B. Both the cars starts from the rest and they travel with a constant acceleration a1 and a2. Then we have to calculate that v, and this v is equal to what? So basically it's a Narayana's materials question, that is a level 3 అనుకుంటా. level 3లో ఉంటుంది. If you already solved that level 3 questions, then you can directly go for this option. Sorry. You can directly go for that option, right? Let's solve the question. So let's highlight what is there in the question. Car A takes time t less than the car B. సో కార్ అయితే కంపేర్ చేస్తే కార్ బి టైము తక్కువ ఉంది, ఎంత టీ సెకండ్స్. అండ్ కంపేర్ ద స్పీడ్స్. సో స్పీడ్ వి మోర్ దెన్ ద కార్ బి, స్పీడ్ ఏమో కార్ బి కంటే ఎక్కువ ఉంది. అండ్ వీ హ్యావ్ టు ఫైండ్ అవుట్ ద రిలేషన్ బిట్వీన్ ద యాక్సిలరేషన్స్ ఇన్ ద టైమ్, రైట్? సో I'll draw the diagram. So that is a car A and a car B. So that was a car A and a car B, and a car A is taking this much of time, that is time of a car A is equal to time of a car B minus t, and the speed of a car A is equal to speed of the car B plus v, right? And both are starting from rest, therefore you can take this u is equal to 0, and you can also take u equal to 0 because the both are starting from a rest, right? Let's solve the problem. So it is traveling this much of distance, both are traveling the same distance, s and s. So according to the kinematic equations, let's say logic number 1. The logic number 1 is equal to we have s equal to ut plus half at square. We have s equal to ut plus half into a into t square. So here I could say s is equal to, since this initial velocity is 0, right, half into a1 into, we could say that it is nothing but a t1 square. Therefore t1 is equal to under root of what? Under root of 2 s by a1, right? So similar, we could say that this is t2, this t2 is equal to under root of what? Under root of 2s by, that is a2, that is where a1 and a2 are accelerations of a car A and a car B, t1 t2 are time of car A and time of car B, right? So since from this equation we could say that this t1 is equal to, since, so let's say logic number 2, since t1 is equal to t2 minus t, therefore we could say that this t is equal to t2 minus t1, right? t2 minus t1, so that could be written as, t2 can be written as what? Under root of 2s by a2 minus under root of 2s by a1, right? Therefore if you take out this under root 2s out, so that will be like 1 by under root a2 minus 1 by under root of a1. So if you find out this LCM, that will be, that is what? Under root of 2s, this can be written as under root of a1 minus under root of a2 by, this can be written as under root of a2 a1, right? So this is what we will have, that is what? Time. And here there is one more case, that is velocities. If you find out a velocities, so this much distance they are moving, right? So since according to the kinematic equation 3, according to kinematic equation 3, we can write this v is equal to under root of 2 into a into s. If it is for a car 1 or car A, we can write as a a1. If it is for a car B, we can write as the what? Under root of 2 into a 2 into s. Therefore these equations can be written as t equal to, this can be written as under root of 2s a1, right, minus under root of 2a, sorry, this one not, this is a2. Therefore by we have this under root of a1 a2, right? Under root of a1 a2, therefore time t equal to this 2as1 can be written as v1 minus v2 by under root of a1 a2, right? That can be written as under root of a1 a2. Now what we left, let me write here. So this, therefore time t equal to under root of 2a v1 minus v2. Here this is a v1 will be equal to, this is a v2 plus I have a v, therefore I have a v is equal to v1 minus v2, right? So in the place of v1 minus v2 we can write this one v, therefore we have a v by under root of a1 a2, therefore this v is equal to under root of a1 a2 into t, right? That is the answer for this question number 1. That was the answer for the question number 1. Hope you understood. Let's see the question number 2. Let's see the question number 2. What the question number says: two trains which are moving along two different tracks in opposite directions are put on the same track due to a mistake. The drivers, on noticing the mistake, start slowing down the trains when the trains are 300 meters apart. Graphs given below shows their velocities as the trains slow down, the separation between the trains when the both have stopped. If you try to solve this problem by relative velocity concept, that might be somewhat tougher. It's better to solve the problem in a graph based method. We know the logic. Logic is simple. The logic is the velocity under time under velocity under time graph will be the displacement. Here also the area under this area, the area under this area will be the displacement. Here this area will be the displacement, right? So you're gonna find out the displacements in both the cases. So if you find out in a if you find this area, this area will be the displacement of this, and if you find out this area, this will be the displacement of the second graph in a time of 8 seconds or until it stops, right? So initially there is a 300 meter separation between a train 1 and a train 2, and if you find out this area, right, what is that area will become? So we have this area is equal to half into base is how much? Base is a 10, right? The base is a 10 into height is how much? Height is a 40, cancelled out, I have a 2, therefore I have this area is equal to how much? That will be equal to 80, right? My mistake. That will be equal to 80 meters, and here coming to here, this area under this graph, will be like same, that is half into base is how much? 8 into height is nothing but 20, right? 4 times, that will be equal to 80, right? So 80 and 80, therefore here there is a difference of how much? So that will be like 300 meters, right? That will be like 300 meters. So let's say this is a train 1 and a train 2. So how much that will be like? So one is moving in a forward direction, other one is moving in a negative direction. Like one is having a positive displacement, other one is having a negative displacement, right? So therefore this is how much? This is 80, and this is 5, right? That will be like 200. Sorry, my mistake. That will be like 200, right? So this is moving a distance of 200 and it is moving of 80. Therefore the separation between these two will be how much? That will be like 20 meters, right? Sorry for the calculation mistake. So this is 5 times, so 5 into 40 is nothing but like 200, right? So therefore the answer is 20 meters. Answer for the second question is 20 meters, right? That was a calculation mistake, sorry for that. Third question: a particle is moving with the speed v, that is equal to b under root x along the positive x-axis. Calculate the speed of the particle at a time t is equal to tau. So we have equation v is equal to b under root x. So this is a given equation, that is a v is equal to b under root x. We have to solve the problem, right? Let's do the calculation part. So since we know that v is equal to p under root x, right? This v can be written as dx by dt, instantaneous velocity, b into under root x. Therefore I can write as that dx by root x will be equal to, I can write as a b into dt. So if I apply the limits from 0 to x and here also from 0 to t, so this will be like how much? 2 root x, right? Will be equal to, this one can be written as a b into t. So therefore if I just squaring on both sides, that will be equal to 4x will be equal to b square and t square. Therefore x equal to b square t square by 4. Therefore to find what we need to find out a speed again, right? Again differentiate it to find it, because we get this displacement, we will have a dx by dt will be equal to, if we differentiate, we will have a b square 2t by 4, right? And we have to integrate up to 0 to tau, right? So this everything will be tau, it's also tau, right? So therefore this one will cancel. Therefore we have a v, or a speed is equal to b square tau by 2, right? b square tau by 2, so that's the answer. So that was the answer for the third question, right? Hope you understood. Question number 4. So the question number 4 is, a ship A sailing due east with a velocity of 10 km per hour happens to appear sailing due north with a velocity of 5 km per hour to a person sitting in a moving ship B. Determine the velocity of a ship B. So question is, there are two ships, ship A and ship B. Ship A is moving towards east. So ship A ఏమో towards east పోతుంది, అండ్ షిప్ బి ఎటు పోతుందో మనకు తెలియదు. బట్ బీలో నుంచి చూసేవాడికి ఏ మాత్రం నార్త్ వైపు పోతున్నట్టు కనపడుతుంది. సో దట్ ఈస్ వాట్ ఐ డ్రా హియర్. షిప్ ఏ ఈజ్ మూవింగ్ టువర్డ్స్ ద ఈస్ట్, రైట్? సారీ, change the pen. Ship A is moving towards the east, and let's say it is the east direction, and velocity of A with respect to B, I mean velocity of ship A with respect to B is 5 km per hour, 5 km per hour, that is towards the north. Therefore if we draw the diagram, we know that velocity of A with respect to B can be written as velocity of what? Velocity of A plus minus velocity of B, right? So we don't know this velocity of B. Therefore what we are writing is velocity of B equal to velocity of A minus velocity of A with respect to the B. So we have a B equal to, velocity of A is how much? 10, that is the 10 I cap minus 5 j cap. Therefore that is a vector. So we have a VB equal to what? VB equal to under root of 10 square plus 5 square, that is 125. That is under root of 125. Under root of 125 can be written as what? Can be written as 5 root 2 5. This can be written as a 5 root 5 kmph, that is a kilometer per hour. So that is the velocity of a B. But we have to calculate what? We have to calculate a direction, right? Therefore for direction we will use these two, right? So with respect to x-axis or with respect to east, we could say that, therefore velocity of let's say the directions. So that will be in a direction, that will be in a third quadrant. So that will be in a, that is in a fourth quadrant, right? Like this one. So this is, that will be in a fourth quadrant. That will be, this is like what? Like this. So this will be 5, right? This is 5 and this will be like 10. This is like a 10. Therefore this angle will be how much? This angle will be tan inverse of 2. So all our answers in a tan inverse of 1 by 2, right? Therefore we need to find this angle. Oh, sorry, opposite by, right, this angle, that is how much we have a theta equal to tan inverse of opposite is how much, 5. I'll have a 10, that will be like tan inverse of 2. Then these I have a tan inverse of in which direction, so this direction, this is what, east of south or south of east, it is a south of east, that is a south of east, therefore option 1. Answer for this question is option 1. That was the answer, right? Now look at the question number 5. Two guns A and B can fire bullets at speeds 3 km per second and 5 km per second respectively from a point on a horizontal ground. They are fired in all possible directions. The ratio of a maximum areas covered by the bullets fired by the two guns on the ground is. So here the diagram, we have two bullets. One is having a 3 km per second, other one is having a 5 km per second. Then we have to find a ratio of a maximum areas. So here we have to find a ratio of a maximum areas. You know the maximum area formula, right? Like first of all you have to know the range formula. Therefore let's say logic number 1, we have a range is equal to, we have a range, 1 second, I have a range equal to u square sine 2 theta by g, right? Therefore we have a range should be maximum, or we have a maximum range. When we have maximum range, when this theta will become a 45, you know that, and that will be nothing but a u square by g. So that's follows the logic number 1. And logic number 2 is area. So area will be like a circle area. Why it is circle area? Because if you throw in all directions, that will make a circle. Therefore this area is directly proportional to r square, and that is also directly proportional to what, u power 4. Therefore we have a a1 by a2 will be equal to u1 by u2 whole power 4. That will gives an answer for that, right? So that's the logic number 2. And this question number 6, a plane is inclined at an angle of alpha that equal to 30 degrees with respect to the horizontal. A particle is projected with a speed u that equal to 2 meters per second from the base of the plane, making an angle theta is equal to 15 degrees with respect to the plane as shown in the figure. The distance from the base at which the particle hit is closer to, right? So this one, that's our diagram for the question number 6. That's a diagram for the question number 6. Have a look. So the velocity of the body is 2 meters per second with the plane that is making an angle of 15, and the plane is making an angle alpha with an angle alpha that is 30 degrees with. So we have to find the range on the inclined plane. So in this case, you know the range formula, right? The range formula is, we have a range is equal to like what, 2 u square sine theta cos theta plus alpha, right, by, we can write as a g cos square alpha. So that was this is what we derived when you are in a classes, like when you go in through this revision part, just go through your notes once, right? Now the logic here is sin theta is 15 and cos theta plus alpha, right? This cos theta plus alpha is nothing but a 45, you could clearly say that. And now we have to convert that sin theta. That is the only one thing that is there. That is, we have r is equal to 2 is a 2. This will be like a 4 into this sin theta is nothing but a sin 15, right? It is a sin 15 degrees cos theta plus alpha. Theta plus alpha can be written as a cos 45. There will be cos 45 by, so this is like g, which is nothing but a 10 cos square alpha. Alpha nothing but cos 30 is 3 by 2. Therefore that will be nothing but a 3 by 4, right? So therefore we have r is equal to, and just convert that 2 into 4, which is nothing but 8. So 8 into sin 45 can be written as, this is only one step that you gonna change. Sin 45 can be written as, we can write as a 45 minus 30 degrees into cos 45, right? By, we can reduce 30 by 4, so that 4 will come up, this will be like 32. If this 4 comes up, this will be like a 32 by 30, right? Therefore we have a range formula, r is equal to 32 into sine, this can be split into like sine A cos B, right? Minus why I wrote A here, 45, sorry, this can be written as sine 45 cos 30 minus cos 45 sine 30, right? Into you have a cos 45, right? By you have a 30. So solve it, you will get an answer. You will get an answer approximately like 20. Therefore that's answer. You already solved this derivation part in the class, so once you just go through that notes, you will understand, right? So answer for this, you will get approximately as 20. Just check it. So that was answer, right? So next one, a tennis ball is released from a height h, and after freely falling on a wooden floor, it rebounds and reaches a height of h by 2. The velocity versus height of the ball during its motion may be represented graphically by. So it seems like a previous year question, right? This one, if it's a previous year, yeah, right, it's a previous year question. If you solve the previous year question, you can directly go through this option, that is option A. The answer for this question is option A. So let me explain. I didn't draw the graph for this because I know it's a previous year question, that's why. So if you want me to explain, let me show the color. I'll do it here. So we know that when the ball is freely falling, like when it is freely falling onto the ground, when it's freely falling onto the ground, so we have a V is equal to under root of a 2 into G into H. This V is, or V square, is directly proportional to H, therefore it is going to be like parabola. That is going to be like parabola. Let's say if it is starting here, if it is going down, the velocity will be increases, but it is increasing. Because of this relation, we fixed it is a parabola. Because of that relation, we fixed it as a parabola. Therefore, this graph is wrong, and you have only choice this one, either this one, right? Only these two. Sorry, only these three. That option B you can eliminate. So that is a parabola. But here, when the ball is dropping or when it is falling down, the velocity will increase, but the velocity is increasing in a negative direction. So therefore, it has to be increased in a negative direction, right? That has to be increased in negative direction. So therefore we can go with this option, we can go with that option, right? We can go with that option. And you know, it's like a velocity and a displacement curve also, you could say that, right? If you just differentiate it, you will get a G as a negative. So this one, right? Now it will come here. So when it just rebounds back, the velocity will suddenly become positive. If the velocity will become positive, so this is, so you can go with this. This one is wrong because this velocity is not going to be 0. After it is falling down, the velocity is going to be here. The velocity is going to be here. It is not going to 0. So this is wrong. And you can go with this option, these two. You can go with the option A or option C, right? You can eliminate this option B and option D. You can go with option A and option D. If you can differentiate it, you will get this acceleration, right? The acceleration will be like what? Just find out the slope of all this, and you will get this A, option A. Right. Now question number 8. You have question number 8. There is a helicopter rises from rest on the ground vertically upward with a constant acceleration g. A food packet is dropped from the helicopter when it is at a height h. The time taken by the packet to reach the ground close to. So this is also covered in a revision part. So I will tell you, when the food packet is dropped from any helicopter which is moving up, so this food packet won't fall like a freely falling body. It will feel like a vertically projected from the top of the tower case. Right, so that will falls like that. It is having acceleration g here. It is moving with the constant acceleration g. That is moving with the constant acceleration g. It's moving with the constant acceleration g. Therefore, you can write this equation like I have a logic number 1, that is kinematic equation. S is equal to ut plus half into a into t square. Therefore, when it goes up like x distance and h distance, so you could say that is nothing but x minus x plus h, right? Sorry, minus h. There will be like x minus h will be equal to, so this will be nothing but ut. This can be written as a minus of into g into t square, right? So therefore this x minus x get cancelled. Therefore we have h is equal to ut minus half into g into t square, right? So now we have to find this one. What we're gonna change, what we're gonna do is, we don't have this u, therefore when it is reaches here, when it reaches to this side, this velocity will be equal to u is equal to under root of 2 into g into h, right? So substitute that, allow h is equal to under root of 2 into g into h into t minus h minus of into g into lava t square. Therefore you could write this what? You could write it as of g t square minus under root of j into h into t minus h is equal to 0. And solve it for the roots. Find the roots, you will get answer. And the answer will be approximately what? This answer will be approximately this one, lava 3.4. This is also one of the previous year's question, right? Everything is from previous years. There are 4 marbles. Question number 9. There are 4 marbles are dropped from the top of a tower, one after the other, with an interval of 1 second. The first one reaches the ground after 4 seconds. When the first one reaches the ground, the distance between the first and second and the third and the fourth. Right. So this was the diagram, and it is taking 4 seconds to come down. Right. It is taking 4 seconds to come down. That is freely falling. Therefore, you could say that this h is equal to half into g into t square. Right. You know that will be like half. Therefore, I have h is equal to half into g into t square. What is the t? Is there any height? There is no height. Right, 1 second, I will solve it. So there will be like a 16, therefore cancel that out. I'll have h is equal to 8g. We have h is equal to 8g, right? So this height will be equal to 8g. This total height is equal to 8g, nothing but 80, so nothing but 80 meters, right? So now we have to find between a first and a second and everything, like first one, second one, third one. So since there are 4 drops and the time is 4 seconds, so each one will have a 1 second, 1 second, 1 second. Therefore you guys can do that problem, right? Let's say this third one will be traveled like h3 will be equal to half into g into third one will be traveled how much distance. Third one might travel how much time, that will travel 3 seconds, so let's say 9. So we have this h3 is equal to how much is it? This will be like 9 by 2, 4.5 into g, right? In the same way we can write this h2 is equal to how much time that might be traveled, 2 seconds, therefore that will be 4, so cancel. Therefore we have h2 is equal to what? h2 is equal to what? That will be like 2 times, so lava 2 into g. So that is how we can solve from 1 to 1, 1 to 1, right? So that was easy question. And question number 10. Question number 9 is easy. Question number 10, right? So a ball is thrown off with a certain velocity so that it reaches a height h. Find the ratio of the two area. It's also like previous year question. The ball is thrown with a certain velocity so that it reaches a height h. Find the ratio of the two different times of the ball reaching h by 3 in both directions. So let's say in both the cases the height is h by 3. Again this question can be written as by using this s equal to ut plus half it square. That can be solved by using the equation s equal to ut plus half it square. Therefore let's say we have a s equal to ut plus half into a into t square, right? So this it is moving up, therefore we could say that this is h by 3. h by 3 is equal to, since it is moving with let's say velocity u, so we can write as a u t1 minus of into g into, you could say that is nothing but a t1 square. Again that will be like a h by 3 equal to, we have a u into t2 minus of into g into t2 square, right? So what we need to do here, in order to solve this, we have to write this. Let's do one thing, like find out roots in this case. Like first one, allow h by 3 will be equal to u can be written as under root of 2gh. Where that comes from, you know that this is the maximum height, so we have h is equal to u square by 2 into g, and we have a u is equal to under root of 2 into g into h. Therefore we have under root of 2 into g into h into, you can write the t1 minus of into g into, you can write the t1 square. So find out the roots here, right? And here also we have a like a t2, t1 and a t2. Find both from this equation, you will get it as a t2. Like if you write that quadratic equation and find out a root t1 and a t2. But here logic is that when you're writing a quadratic equation, there is a case like minus b plus or minus under root of b square minus 4ac by, we have a 2 into a, right? So here the condition is that when you're finding a time t1, you will take here it is a minus. When you're finding a time t2, will take it as a plus here, because you guys can clearly see that this t2 should be greater than a t1, that's why, right? So repeating, when you're finding a t1, take it as a minus here. When you're taking a t2, take it as a plus here. So find out the roots and just divide them, you will get an answer. That's the question number 10, right? So question number 11, the ranges and heights of the two projectiles projected with the same initial velocity at an angles of 42 degrees and 48 degrees, which the horizontals are r1, r2 and h1 and h2 respectively, choose the correct option. So you could clearly see that this is option, this one. r1 is equal to r2 and h1 is less than h2. Why? Because this 42 degrees as well as the 48 degrees, they both are complementary. When the both are complementary, you could say that r1 is equal to r2, so you can eliminate this option D and option A, you can eliminate these two, and you have only one choice, that h1 is equal to h2. h1 never will be equal to h2, therefore this answer is C, right? So that's the question number 11. A bomb is dropped by a fighter plane flying horizontal to an observer sitting in the plane. The trajectory of the bomb is hyperbola, parabola, no, I think it's like a straight. Why that was a straight? So this guy is in the plane, so there is a guy, and there was a guy, and this guy is also moving with velocity u, right? So in a horizontal direction, if you find out the relative velocity in a horizontal direction, that will be equal to 0, because they both are moving in the same direction. So there is no horizontal velocity. If there is a horizontal velocity, if there is a relative horizontal velocity, then only this ball or a bomb will move in a parabola, since there is no relative velocity along a horizontal, right? So the boy has to move along a vertical, right? Along a vertical, because the horizontal velocity or relative horizontal velocity will become 0. Therefore the answer for this question is like this one, that is option what? And the option is this one, that is straight line vertically down the plane. Why? Because there is no horizontal relative velocity with respect to man of a bomb. And question number 13, I am not solving it, we already done in the class. I told you in both the sections in our top classes, therefore I am not doing it. You can directly keep your answer right, under root of t1 t2 by t2 plus t1. I told you why. So you can maybe better anukuntuna, right? So question number 14, so this is one of best out of this. It's also like a previous year question, but still best. So the velocity of a displacement graph describing the motion of a bicycle shown in the figure, right? So you know the basic of this. Let me. So you know that acceleration A is equal to, you can write the dv by dt. That's the basic one. Allow A is equal to, if I just rewrite the terms, you know how that will be like a v into dv by dx, right? So therefore that's the acceleration. Acceleration is equal to a equal to v into dv by dx. So for this slope, for this line, like this line, right, the slope is how much? For that line the slope is how much? You could say that this is how much? This will be like a 40 and this will be like a 200, right? Therefore you can find out the slope of it. Allow dv by dx is equal to what? Dv by dx is equal to 40 by 200. That will be like 1 by 5, right? And you want to find out this v, so you can write start an equation for this, that is y is equal to, you have a mx plus c, right? So you have a v is equal to, m can be written as 1 by 5 plus 1 by 5 into x is x plus c. You could clearly see that c is nothing but a 10, right? So this is what, that is a v, and therefore you could say that this acceleration is equal to 1 by 5 into x, that is x by 5, plus you have a 10 into this can be written as a v can be written as what? So slope can be written as 1 by 5. Therefore a equal to x by 25 plus you have a 2. So that's going to be like a straight line equation. If you keep x is equal to 0, this acceleration will be equal to 2. If you keep 200, that will be like 10. Therefore you could say this one. So there is a possibility for these 2 grams, but still if you look at this 200 to 400, the slope is 0 here. The slope in this graph is 0 here. Therefore if the slope is 0, acceleration will be equal to 0. Therefore this graph is wrong and this graph is right. So that's the answer for the question number 14. That was the answer for the question number 14, right? So now let's see question number 15. So the path of a projectile in the absence of air drag is shown in the figure dotted by the line. If the air resistance is not ignored, then which one of the following? If there is air resistance, you guys know that range formula, right? You guys know that range formula. Range is equal to u square sine 2 theta by g if you do not consider the air. But if you consider the air, that can be written as a u square sine 2 theta by, we have a g plus a. Since this denominator increases, this r will be like decreases. Same way we have a height formula, h is equal to, this can be written as a u square sine square theta by, we have a 2 into g if you do not consider the air. But if you consider the air, that will be like h is equal to u square sine square theta by, we have a g plus a. Again this denominator is increases, therefore this h will be decreases. So both range and height will be decreases. That is option B. I mean answer is, for that the correct graph is a B, therefore option is A, right? Now this is a one more important question, question number 16. That was interesting. The displacement of a particle is given by x equal to t minus 2 whole square, where x is in meters and t is in second. The distance covered by the particle in the first 4 seconds is. So the displacement is given, that is x equal to t minus 2 whole square. Find distance in 4 seconds, right? Let's do it. So we have a x equal to t minus 2 whole square. If I differentiate lava dx by dt will be equal to lava 2t minus 2 into lava 1, that is a velocity. This velocity can be written as I have a 2t minus 4. And if I go with the acceleration, lava acceleration is equal to 2, that is we are having a constant acceleration, that too positive, right? But there is a condition, like for example if we keep velocity is equal to like a time 0, at time t is equal to 0, velocity is a minus 4. That means it is moving in a negative direction, right? It's moving in a negative direction. When a time t is equal to 1 second, that is nothing but a minus 2. When time t is equal to what? When time t is equal to 2, that will be equal to 0. like let me write here, at a time equal to 0, velocity at a 0 will be equal to minus 4, that's moving in a negative. Velocity at a 2, velocity will be 0. Velocity at a 4, so lava 2 into 4, 8 minus 4. 8 minus 4 is nothing but a 4. Therefore, if you draw the graph seems like this. It's better to do with the help of a graph. Sorry. Right. So if I draw the graph might be like this, right? So this is minus 2, so this is a minus 4, and this is what? This is at what? This is at time t is equal to seconds, and this is time t equal to 4 seconds, right? This is a 4, and find out these two areas to find out the distance. Find out these two areas, you will get an answer. Find the two areas, you will get find the two areas and add them, you will get answer, because it is a velocity and a time graph. So if you find out area, there will be displacement, but if you both add in a negative and a positive, there will be like displacement, right? So you know that. In question number 17, that was an easy one. So there is a train A and a train B, they both are moving in the same track, and to avoid the collision, so what must be the retardation? To avoid the collision, what must be the retardation of A? So let's say do it by using this relative velocity method, that will be better, right? So we have a v relative square equal to u relative square, you could say that plus 2a relative and s relative, right? So to avoid the collision, this v relative should be equal to 0, and this u relative will be like both are in the same direction, so you can do the v minus v, like minus, because it is going to retard, so there will have a 2 into this a retardation that we have to calculate, into we have a s relative is nothing but a x, therefore we have a 2a x equal to v minus v, therefore we have a x equal to sorry, we need to find retardation, right? Therefore we have a equal to v minus v by, you can directly write as a 2 into x. So that's the answer for this question number 17, right? So that's the question number 17, and question number 18, 19 and 20 all are like easy problems, no need to solve them at all, because all are direct problem formula based, right? The horizontal range of projectile fight at an angle, you know the direct formulas for them, just apply the direct formulas and you will get an answer, right? So this is a part 1, and I will apply that part 2, that is numericals, tomorrow morning, right? So that's for this 20 questions. So I'm not solving this 18, 19, 20 because those are directly formula based. You know this maximum vertical height formula, that is there is a relation between them. You can directly write this h max is equal to r max by 2, so you will directly get this, right? The maximum vertical height, which can be like you can write 138 into 2, that's nothing but a 276. This will be answer. This 18, 19, 20 are like a direct formula based, there is no suspension in them, so that's it.